Hello everyone, this is Aditya and today we'll be solving some of the PYQs from JEE Advanced on the topic quadratic equations and inequalities. So let's see what are the questions today, and before that please do like, share, subscribe and please support this video. Let's start. So let's start with the first question. Let alpha beta be roots of the equation x square minus px plus r is equal to 0. So alpha beta are the roots of this quadratic equation x square minus px plus r is equal to 0, right? Okay. And be roots of the equation x square minus qx plus r is equal to 0. Okay. Then what is the value of r? This is from IIT JEE 2007. Okay. So let's see. So we have four options: A 2 by 9, P minus Q, 2Q minus P. Option B 2 by 9, P minus Q times 2P minus Q, and we have C option 2 by 9 Q minus 2P times 2Q minus P. Okay. And what's the option D? Option D is 2 by 9 2P minus Q times 2Q minus P. Okay. So this is the question. The question states let alpha beta be roots of the equation x square minus px plus r is equal to 0. So this is a quadratic equation, and let alpha by 2 and 2 beta be roots of the equation x square minus qx plus r is equal to 0. Sorry. Then what is the value of r? Okay. And here we have four options, and it is a single correct option. I mean single correct question. Okay. So 2 by 9 P minus Q times 2Q minus P and 2 by 9. So these are the options in terms of P and Q. So we have to solve R in terms of P and Q. So let's see how we can solve it. Okay. So let's see it. So it seems to be a difficult question, but it's actually very easy, because you have to just notice one thing over here, that this equation has roots alpha and beta, right? So sorry, this is R not gamma, has roots alpha and beta, correct? And the second thing to be noticed is has roots alpha by 2 and 2 beta, correct? Okay. So clearly from the formula alpha beta is equal to R, right? This is a basic property that the product of roots is equal to the coefficient with I mean this constant term over here, right? Okay. Alpha beta is equal to R. So it means that we have to write alpha in terms of P and Q and beta also in terms of P and Q. Okay. So we know another formula, alpha plus beta will be equal to P. Sum of roots is negative the coefficient of x, right? And alpha by 2 plus 2 beta is equal to Q, correct? Okay. Let's multiply this equation by 2. So you will have alpha plus 4 beta is 2Q and alpha plus beta is equal to P, correct? So from here just subtract this equation, you will get these two equations. You will get 3 beta is equal to 2Q minus P. So you have beta is equal to 2Q minus P by 3, correct? Okay. So from here you can say that means you have got that beta is equal to 2Q minus P by 3, right? Okay. Now just multiply this equation by 4. So you'll get 4 alpha plus 4 beta is 4P, correct? And alpha plus 4 beta is 2Q, correct? When you solve it, right? So alpha is 2 by 3. I have taken 2 as common, right? 2p minus q, correct? Okay. So alpha is 2 by 3, 2p minus q. So alpha times beta will be equal to 2 by 9. 2 alpha is 2p minus q times 2q minus p. Which is the option which is matching with our answer? Option number D. 2p minus q, 2q minus p, 2p minus q, 2q minus p times 2 by 9. Okay. So this is the answer. So now let's move to the second question now. Okay. Now let's see question number 2. Okay. So let R denote what? Set of all real numbers. Okay, that's obvious. And let AI and BI belong to real numbers. Okay. For I belonging to 1, 2 and 3. Okay. Okay. So we will define a function. Define a function f from real to real and g also from real to real and h also from real to real. Okay. So we have defined a function and fx is given by a1 plus 10x plus a2x square plus a3 x cube plus x raised to the power 4. Okay, right. And gx is b1 plus 3x plus b2 x square plus b3 x cube plus x4. And h of x is given by function at x plus 1 minus function at x plus 2, g at x plus 2, and we are given f of x is not equal to g of x. Okay, that's a very crucial thing which we have to note. Okay, for every x belonging to real number, then coefficient of x cube in h of x is. Okay, so this is from JEE Advanced 2025 paper 1. Yeah, it's from paper. Okay, so let's understand the question first of all. So we are given let R denote the set of all real numbers, that's obvious, and let ai comma bi belong to real numbers for I belonging to 1, 2, 3. Okay, so basically this is a1, this is a2, this is a2, this is a3, this is b1, b2, b3. So they are belonging to real numbers. Okay, and hx is given as function at x plus 1 minus g at x plus 2. Okay, so and we are given fx is not equal to gx for every x. Basically it is true for all x. It means that from here it basically means fx minus gx is equal to 0 will have no real roots. This statement means this. How? Because of course if fx minus gx will have a real root, then it would imply that fx minus gx is equal to 0, which means that fx is equal to gx for some value x. But here we are given that for every x, it means that there exists no such x, right? So it means that from here if we substitute fx, so fx is a1 plus 10x plus a2 x square plus a3 x cube plus x raised to the power 4 minus b1 plus 3x plus b2 x square plus b3 x cube plus x raised to the power 4 So if it is equal to 0, then of course, if we set it equal to 0, then it should have no real root. Okay, we want this. So here we will get a1 minus b1 plus 7x plus a2 minus b2 x square plus a3 minus b3 x cube is equal to 0 with no real root. No real root. Okay, we want this. Okay, now notice one thing. This is a cubic polynomial, right? This is a cubic polynomial. Suppose it's not equal to 0, so it is a cubic polynomial, right? And a cubic polynomial always have at least one real root. Why? Because you try as much as possible, it can go like this at max, or it can go at max like this. You will have at least one real root if it is a cubic. But if it is a quadratic, then of course maybe or maybe not. It's possible that the both roots are complex. So it means that this equation should not be cubic equation, which means that a3 minus b3 must be equal to 0. That is, the coefficient of this should be equal to 0. So it means that a3 is equal to b3. So we have this equation, a3 is equal to b3. Means we have this relation between a3 and b3. Okay. Now let's come to the original question. So this from this statement they wanted to infer this, that a3 is equal to b3. Okay, right. So now let me erase this and let's solve the original problem. Okay, fx this. Okay, so let me erase this. So we had h of x is equal to function at x plus 1 minus g at x plus 2, right? Where fx a1 a3 x cube x to the power 4 b1 3x plus b2 x square b3 x cube, right? Okay, so we want the coefficient of x cube from here. So let's see. So what will be function at x plus 1? It will be a1 plus 10 x plus 1 plus a2 x plus 1 whole square plus a3 x plus 1 whole cube plus x plus 1 whole raised to power 4, correct? So in coefficient of x cube, will there be any term related to a1, the x raised to power 1, x raised to power 2? No. So we can just simply neglect them. And over here also, there will be only one term of x cube. So what we will be left with is coefficient of x plus 1, of x cube in function at x plus 1 will be equal to what? a3, and from here x plus 1 raised to the power 4 will be equal to what? 4c0 x raised to the power 4 plus 4c1 x cube. So plus 4c1. Okay, so it is equal to what? It is equal to a3 plus 4, correct? Okay, and similarly for g of x plus 2, it's b1 plus, of course you can neglect these terms, and over here b3 x cube plus x plus 2 raised to the power 4 4c0 x plus 2 4c1 x raised to the power 3, correct? Raised to the power 1, of course this. Okay, not 14, this is 1. Okay, so we want this term plus 8, correct? So we have the coefficient of x cube in h of x as a3 plus 4 minus b3 plus 8, which is a3 minus b3 minus 4. Now a3 minus b3 was equal to 0. So this is equal to negative 4. So it means that the coefficient of x cube in h of x is equal to negative 4. Now let's move to the next question. Question number 3. Okay. Let p, q be integers. They are integers, and let alpha comma beta be roots of x square minus x minus 1 is equal to 0. And of course alpha is not equal to beta. We can clearly see also. And an is p into alpha raised to the power n plus q beta raised to the power n. So a12 is equal to what? Okay. Option A, a11 plus 2a10. Option B, 2a11 plus a10. Option C, a11 minus a10. Option D, a11 plus a10. Okay. So let's see. So the moment you see such kind of expression, you immediately realize that over here we have to apply Newton's theorem. Okay. So let's see. So we have the expression x square minus x minus 1 is equal to 0. Now you all have studied Newton's theorem like alpha raised to power n plus beta raised to power n in that form. So the moment you see such form, you get confused, but there's nothing to be confused over here. Let's substitute alpha. So you'll get alpha square minus alpha minus 1 is equal to 0. Multiply by alpha raised to power n minus 2. So you will have alpha raised to power n minus alpha raised to power n minus 1 minus alpha n raised to power n is equal to 0. And now multiply both sides by p. So you will get p alpha raised to power n minus p alpha raised to power n minus 1 minus p alpha raised to power n minus 2 is equal to 0. Similarly, try it yourself. Okay? The method is same. Okay, just add both sides. P alpha n plus q minus p alpha n minus 1 plus p beta n minus 1 minus p alpha n minus 2 plus q beta n minus 2 is equal to 0. Correct? So this is an minus 1 minus an minus 2 is equal to 0. So the moment you substitute over here 12, you will get this equal to a11 plus a10. Okay, understood? Okay, so now let's erase this and let's move to the next question. Okay. And of course this is from JEE Advanced 2017 paper 2. Okay, so let's erase this and let's move to the next question. Question number 4. Let theta belong from minus pi by 6 to minus pi by 12. Okay. Suppose alpha 1, beta 1 are the roots of the equation x square minus 2x. I am not writing the complete question, but this is the meaning. Okay. Plus 1 is equal to 0. Okay. So the alpha 1, beta 1 are the roots of the equation, quadratic equation x square minus 2x into sec theta plus 1 is equal to 0. Okay. And alpha 2 comma beta 2 are the roots of x square plus 2x tan theta minus 1, and alpha 1 greater than beta 1, alpha 2 greater than beta 2. Then what is the value of alpha 1 plus beta 2? Okay, so we have to find this. Options are 2 times sec theta minus tan theta. Option B, 2 sec theta. Option C, negative 2 tan theta. Option D 0. Okay. Now many people think that 0 seems to the most odd option out of 4. So many people take 0 as the answer, but that is not correct. Okay. So now let's see the solution. Okay. So we have this quadratic equation x square minus 2x sec theta plus 1. Okay. So we can clearly solve this. This is very easy. So x turns out to be, I am solving this one, 2 sec theta plus minus root 4 sec square theta. 4 sec square theta minus 4 by 2. Right? Now I'm going to solve this one. Minus 2 tan theta plus minus root 4 tan square theta plus 4 divided by 2. Correct? So now let's solve for x in this equation. So x is equal to, of course, 2 will get cancelled. So you'll have sec theta plus minus square root sec square theta minus 1. So x is equal to sec theta. What is sec square theta minus 1? Well, it is equal to tangent theta, right? Okay. Tangent square theta, right? So plus minus tan theta, right? Okay. So we have alpha 1 as sec theta minus tan theta and beta 1 as sec theta plus tan theta. Correct? Why? Because we are given that alpha 1 is greater than beta 1, right? Which implies that alpha 1 should be sec theta minus tan theta. Why? Because the domain is from negative pi by 6 to negative pi by 12. So in this domain, tangent will be, of course, negative and sec theta will be positive. Correct? So this is positive minus a negative quantity will be positive plus positive. But over here, it will be a positive value plus some negative value, which will be, of course, less than this value. Okay. So this is alpha 1 and beta 2. Sorry, beta 1. Okay. Similarly, x is over here minus tan theta plus minus root tan square theta plus 1. Correct? Okay. So you'll get negative tan theta plus minus sec theta. Now you all must be thinking that after taking the square root, we should have written modulus of sec theta, right? But that's not required because we have already plus minus sign over here, right? While proving the formula for quadratic equation, we take that into account, and that's why we put plus minus sign over here. Okay. So from here you get alpha 1 and alpha 2 and beta 2 as negative tan theta plus sec theta, and this as negative tan theta minus sec theta. Again, because sec theta is a positive quantity, so if you subtract it, you will get a more negative value than this. Okay. But it's for sure that alpha 2 will be greater than beta 2 if I assume this like this. Okay. Now just add alpha 1 plus beta 2. So what is alpha 1? Sec theta minus tangent of theta minus tan theta minus sec theta. So you get negative 2 tan theta. So it's option number C. I hope you understood this problem. Okay. So what I have done is that I basically solved for each root and I just analyzed according to the domain that what can be the value of alpha 1 and what can be the value of alpha 2 and so on and so forth for beta 1 and beta 2. Okay. So let me erase this and let's move to the fifth question. Right. Question number 5. Did I mention That question was from which year? It was from JEE Advanced 2016. It was from paper 1. Okay. So now let's see this question. The quadratic equation, the quadratic equation Px is equal to 0 with real coefficients, with real coefficients has purely imaginary roots. Okay. Then the equation P of x equal to 0 has, before writing the option, let me tell you it is from JEE Advanced 2014 paper 2. Okay, so now let's solve it. Okay, so let me tell you the options. The options are A, 1 purely imaginary root. Option B, all real roots. Option C, 2 real plus 2 imaginary. Neither real nor purely imaginary. Now what does purely imaginary mean? The question is the quadratic equation Px equal to 0 with real coefficients has purely imaginary roots. Now purely imaginary term means there is no real term in that. That is, it is of the form I lambda. Right? You write complex number as x plus iota y, right? If x is equal to 0, then z is equal to iota y. It is called purely imaginary number. Okay? So it means that the roots are plus I lambda and minus I lambda of p of x is equal to 0. Right? Okay. So you can write p of x as some constant a, some coefficient, are you able to understand this? If the roots are alpha and beta, then it is given as x minus alpha times x minus beta times some a is equal to the quadratic. Right? That's how you write it. So when you open this, you will get a times x square plus lambda square, not negative. Note this. Okay. Now, what is p of x? It will be a p of x whole square plus lambda square. Okay. A, what is p? P of x? It is a times x square plus lambda square whole square plus lambda square. Correct? Okay. So, to solve for x, you will set it equal to 0. Right? Now let's solve it. When a will go to RHS, it will vanish. Okay. So it will be a times x square plus lambda square whole square plus lambda square is equal to 0. So from here you get, it will be a square, a square x square plus lambda square whole square is equal to negative lambda square. So from here you will get x square plus lambda square is iota lambda by a, of course with a plus minus sign. So you will have x is equal to plus minus square root of lambda square negative lambda square plus minus I lambda by a. So there are of course 4 solutions, but is there any real root over here? Clearly no, there is no real root. Is there any purely real, purely imaginary number? No, we don't have any purely imaginary number over here. Which means that there is no, of course, there are 4 imaginary numbers over here. So of course no. All real? Of course no. 2 real? No. So it means that neither real, of course there is no real, nor purely imaginary. It is not of the form I lambda, right? Okay. So this is the answer. Okay. And one more thing, I know you all must be confused over here. In a quadratic polynomial, if I set it equal to 0 and the roots are imaginary or complex, suppose of the form x plus iota y, then if one of the root is x plus iota y, then the other will be conjugate x minus iota y. So this is the conjugate of this. This is the conjugate of this, or vice versa. Okay. So that is why I assume plus I lambda and minus I lambda. Imaginary roots always exist in conjugate pairs. Okay. So this is how you solve it. Now let's move to the 6th question. The question states number of real solution of sine e raised to the power x is equal to 5 raised to the power x plus 5 raised to the power minus x. It is from IIT JEE 1990. It is a very old question actually. Okay. So how you will solve this problem? You see a trig function, and inside that trig function you see an exponential function, and we have set it equal to 5 raised to the power x plus 5 raised to the power negative x. So how are we going to solve this? Well, sine e raised to the power x, what is its range? Well, e to the power x is always greater than 0, right? Okay. So sine e raised to the power x will always be greater than 0 and less than equal to 1. So it is lying between 0 and 1, correct? Okay. Whether it is equal to 1 or not, that we have to check. So you can assume it less than 1 only for now. Okay. Or you can check that whether it is equal to pi by 2 or not. That doesn't matter even. Okay. So it can be less than equal to whatever you want. Okay. So we have this expression. Okay. You must have heard about AMG inequality. X plus y by 2 is greater than equal to square root of xy. And if you have n entries, x1 till xn divided by n, it is less than equal to the nth root of the product of all these expressions. This is the GM, this is the AM. Okay. Equality exists only when x1 is equal to x2 is equal to xn. Okay. If all the entries are equal, then the equality will exist. Okay. There's another method to write this expression. Sigma xi, I going from 1 to n divided by n, is greater than equal to the product from I going from 1 to n xi raised to power 1 by n. Okay. Correct. Or simply whole raised to power 1 by n, whatever be it. So this is another way to write this thing, but that doesn't matter. Okay. So let's apply AMGM. So over here we have x a as 5 raised to power x and b as 5 raised to power negative x. It is greater than equal to the square root of 5x into 5 raised to power negative x, which is clearly equal to 1. So we have 5 raised to power x plus 5 raised to power negative x is greater than equal to 2. which means that 5 raised to power x plus 5 raised to power negative x is greater than 0, sorry, is greater than 2, which of course is greater than 1. So it means that the range of this function is between 0 and 1, and the range of this function is of course greater than 2. So of course they can never intersect, so the number of solutions will be 0. That's the answer. Now let's move to the next question. Question 7. Number of distinct real roots of the function x raised to the power 4 minus 4x cube plus 12x plus x, so x square plus x minus 1 is equal to 0. Okay, and it is from IIT JEE 2011 paper 2. Okay, right. So how are you going to solve this? Well, you can see it is a biquadratic equation. It has a degree of 4. So of course you can't apply any formula right now to solve or understand this. So we'll be using application of derivative over here. So let's see how you are going to apply it. Since fx is x raised to the power 4 minus 4x cube plus 12x square plus x minus 1. So we have derivative is 4x cube minus 12x square plus 24x plus 1, right? So we have second derivative 12x square minus 24x plus 24. You take 12 as common, so you will have x square minus 2x plus 2. Now clearly, discriminant, if you calculate the discriminant of this function, it will be 4 minus 8, that is, it is a negative value, and since it's a negative value, and since the coefficient of x square is positive, that is, it is 1, so it is a positive quantity, so f double dash of x is always greater than 0 for all x belonging to real number. Correct? So we proved that f double dash of x is greater than 0 for all x belonging to real number. Okay, so it means that since the derivative of f dash of x is always greater than 0, it means that this is an strictly increasing function. This is a monotonic function. And since it's a cubic equation, it means that it will cut x-axis at least once. I mean at max 1, right? Because it's a strictly increasing function, so it will go from negative infinity to positive infinity. So it means that in that domain from negative infinity to positive infinity, it will cut x-axis at least once. And since it's an increasing function, so instead of at least, it will be cutting x-axis only once. Okay, what is that point? Suppose that point is a. So what is f at 0? F at 0 is negative 1. F at 1, it is 1 minus 4. Sorry. We have this one, right? Sorry, it is positive. Sorry. Yeah. And f of 1 is equal to 4 minus 12 plus 24 plus 1. No, this is a positive value. So f at negative 1, it will be negative 4 minus 12 minus 24 plus 1. Of course, it is less than 0. So a is lying between negative 1 and 0. So whatever value it is, we don't care about that. Okay. So it means that there is only one critical point over here, right? So this function, we don't know how it will look and we don't care about it either. But we know that the function will keep on coming down and it will cut the axis and it will go upwards. Of course, this is a very rough diagram that is not required even. This for fx. And where it will go down? at A, right? Over here, correct? This is fx. But you could have asked me that this is also possible. Then there will be no roots, no real roots. Then how I am saying that this is true? Because if you check for function at 0, this is now the function at 0. This is negative 1. This is negative 1, okay? Function is, suppose 0 is over here, 0. Suppose this will be negative 1. Now what is function at negative 1? 1 plus 4 plus 12 minus 1 minus 1, which is greater than 0. So this is negative 1. And A lies between 0 and negative 1. Since A lies between 0 and 1, negative 1 and 0, it means that after passing this point, right, the curve will keep on going down, reach a minimum value, and after that it will keep on increasing. Okay, correct? And yeah, so that is why it has exactly 2 real roots. Okay, 2 real roots is the answer over here. Did you understood how I've done? Of course, all these are just sorry, all these are just very rough figures, graphs, to make you all understand what is going on. Of course, that graph will be totally different when you check it online. But the idea is this, that since the critical point is lying between negative 1 and 0, and the value of function negative 1 is positive and at 0 it is negative, so it means that the graph is going like this and it is reaching a minimum value and then it is going upwards again. So it is cutting the axis at exactly 2 points. Okay, so this is how it's working. Okay, so now let's see question number 8, right? So it is a very nice question, you can note this also. Okay, question number 8. A, B, C belongs to positive real numbers. Okay, positive real numbers, basically real numbers excluding 0, and numbers from R plus is R minus 0 union. Basically you can write it like this: R negative infinity to 0. Okay, right? So this so ABC belong to real numbers, positive real numbers. So you have to prove A plus 1 raised to the power 7, B plus 1 raised to the power 7, C plus 1 raised to the power 7 is greater than 7 raised to the power 7, A raised to the power A raised to the power 4, B raised to the power 4, C raised to the power 4. This is from IIT JEE 2004. Sorry. Okay. Now, seeing such kind of problem, many times we think that AMGM inequality will work. So let's see, does it actually work? You can add A plus 1 as correct. You can write it like this. So now what you will do is that you will take A there are 7 terms greater than or equal to 7th root of A raised to the power 4 divided 4 raised to the power 4 times, correct? Okay. Does it prove anything? And it proves this quantity, this expression, but it doesn't lead to this expression. So here you have to apply some other approach. Let me tell you that. And that's the point of discussing this question. Yeah. So we have this expression. So you can observe this expression. When you multiply, what you will get? A plus B plus, of course, plus 1 plus AB times 1 plus C. So when you multiply, you get 1 plus A plus B plus AB plus C plus AC plus BC plus ABC, right? You'll get this expression. Okay. Now take this expression: A plus B plus C plus AB plus AC plus BC plus ABC, right? There are 1, 2, 3, 4, 5, 6, 7. So there are 7 terms. Divide by 7. It will be greater than or equal to 7th root of ABC times AB. This. So there are ABC, A, B, C times AB, AC, BC, ABC, right? Okay. Now just multiply these terms. So you will have A plus B plus C plus AB plus AC plus BC plus ABC divided by 7. There are how many A? There are 1, 2, 3, 4. There are 4 A. So A raised to the power 4, B raised to the power 4, C raised to the power 4. Somewhat similar to this. Okay. Now what we have? What we can do next? Now since we have this expression, now let's multiply both sides by 7. Okay. So A plus B plus C plus AB plus AC plus BC plus ABC is greater than or equal to 7 times 7th root of A raised to the power 4, B raised to the power 4, C raised to the power 4. And of course, if I assume it as t, so it will be of course less than this 1 plus t. So you can say, what is 1 plus t? 1 plus t is this expression. So we have A plus 1, B plus 1. Since all the numbers are positive, so if you are adding 1 to it, it will again yield a positive value which is greater than this value t. Okay. C plus 1 greater than just greater than now, because this was greater than or equal to, so if you are adding 1, so of course it will be greater than. What will you get? 7 times 7th root of A raised to the power 4, B raised to the power 4, C raised to the power 4. Now raise both sides to the power 7. So you will have A plus 1 raised to the power 7, B plus 1 raised to the power 7, C plus 1 raised to the power 7 is greater than 7 raised to the power 7, A raised to the power 4, B raised to the power 4, C raised to the power 4. Correct? That's it. So now let's move to the next question, right? Question number 9. Now you must have observed I did 4 to 5 questions regarding quadratic equations. Now I'm doing the questions regarding inequalities. Okay. So yeah, for every integer n greater than 1, inequality n factorial raised to the power 1 by n is less than n plus 1 by 2. So is it true or false? It is from IIT JEE. Sorry, 1981. Okay, it is a very old question. So let's see. So this is a very straightforward question if you can understand this. Sum of all natural numbers divided by n, apply AMGN, this is n times n plus 1 by 2 times n greater than or equal to, what is this? This is n factorial. So n and n gets cancelled. N plus 1 by 2 . and this is what is written. Okay, of course all the numbers are not equal, so it will be of course greater than this value of this function. Okay, so this is true. Let's move to the next question. This is a very easy question. Okay, so this is the last question of this chapter. What is the coefficient of x raised to power 99 in x minus 1 till x minus 2, x minus 3, right? This from IIT JEE 1982, right? Here we are going to apply Beta's theorem. What is it? You must have studied function fx is equal to a x minus alpha x minus beta, right? And if I ask you to find the coefficient of x raised to the power 1, you simply say it is the sum of roots, the negative the sum of roots. If the function is x minus alpha 1, x minus alpha 2, x minus alpha 3, so on till x minus alpha n, and if I ask you to find the coefficient of x raised to the power n minus 1, x raised to the power n minus 1, then you say it is simply the sum of all the roots with a negative sign. Over here it is a polynomial of degree 100. So its degree is 100 and we have to find the coefficient of x raised to the power 99. So basically we have to just evaluate this thing. Here n is equal to 100. Okay, so it will negative the sum of all the terms of all the roots. So it will negative 1 plus 2 till 100. This is negative 5050. That's the answer. Of course 100 times 100 plus 1, 101 2. So it is 5050. So it is 5050 with a negative sign. Okay, correct. So I hope you enjoyed this video. If you did, then please do like, share, subscribe, and please support this video by like.